everyone. I have a question for you. How do you feel about YAML? So, as we all know, YAML is a configuration language, and it stands for yelling at my laptop. It stands for that for several reasons. One of them can be the language itself, right? YAML it looks nice if you just read it. If you just read a few lines of it, it looks nice. It has some strange things about sometimes how it interprets values and can be a little bit strange, but you can live with that. But another reason why you might yell at your YAML is that you are using it to provision your infrastructure. And to provision your infrastructure with YAML, you might have to write a lot of YAML, actually a ton of YAML. So a different title for this talk today could be how actually coding infrastructure can help you with your YAML anxiety. So if you feel a little bit like I feel about YAML, we want today show you a different way of how you can work with your infrastructure. And the way we want to do this is to actually use general purpose languages like Python, Java, and TypeScript instead of writing YAML. But first, let me take a step back. Small history lesson for you here. How did infrastructure configuration and provisioning actually start? Let me take you back to the Dark Ages. In the Dark Ages, you did everything manually, right? You had wikis, playbooks, and you might have had Bob, who knew everything. And you were always praying that Bob was not on vacation or won in the lottery, so that he was still here when you needed him to figure out something. From there, we evolved a little bit. We started to script everything. So we were writing a lot of bash scripts that were then trying to configure our infrastructure and bring it to a certain state. And that worked, and sometimes it didn't work. The next step, and that was actually the revolution here, was to use tools that helped us to just declare the state we want to have, and then let the tool decide how to get to that state. And this is where we got things like CloudFormation, if you are working on AWS, or things like Terraform. And that's basically where my YAML anxiety started. Coming back to writing a lot of YAML. If you're starting out with infrastructure as code, you might think it's super easy, right? So let's just pick an example here. I just want to build a very simple application, so it should be a web application. For that, I need a load balancer that's connected to the internet. And behind that load balancer, I have a number of virtual machines. That's my Amazon EC2 autoscaling group. So nothing really fancy, just have a public URL to my load balancer. It goes to my instances, and there I have a dummy website. So that's super easy, right? That should just be like a few lines of YAML or whatever, right? Wrong. It's actually a lot. So if you're trying to do this with CloudFormation, what you actually find is that you're writing something like 300 lines of YAML. Not 30, not 13, 300. And when I did this for the first time, that's basically where my fear of YAML started. But why is it this way? Why do we have so many lines of YAML? Well, if we zoom in a little bit into what's actually happening, we can see it's not just a load balancer and an EC2 autoscaling group, it's actually a lot of stuff you have to think about, a lot of configuration options, lots of things you have to decide, and you have to know how to decide. So just to give you an example here, for the load balancer, we have to think about basically its firewall, which is the security group. That's how we call it at AWS. Or for my VPC, which is my virtual private cloud, so basically my private network in the cloud that only I can use, if I need to configure that, I need to think about the networking range, the CIDR range. I need to think about routing. I need to think about subnets. I need to think about availability zones, and so on and so on. And when I've made all of those decisions, in the end, that's when I get 300 lines of YAML. Whew, that's quite a lot. So if you're now thinking, okay, is there maybe a better way? Robert's talking about a better way. Where can we go from here? And the idea is that, as we saw before, when we did everything manually, you basically were this lucky engineer who was hoping that the documentation was up to date or that Bob was still here when you needed him. Then we went to this scripting part where you became a bash engineer. Now you might be in the declarative phase of your journey where you're a YAML engineer, maybe. And the next step maybe could be for you to be a software engineer, meaning using software best practices and programming languages to define your infrastructure. So how does that actually look like? In the past few years, a few tools have come up that actually take this approach where you write your infrastructure in a language of your choice. And you see two of those examples here. So there's the CDK, the Cloud Development Kit from AWS, and there's also Pulumi from Pulumi. I think it doesn't have a special name. And with those frameworks, if you install them, you can pick a language, and then you define your infrastructure in that language. Today, and you might have guessed that, we're looking a little bit more at CDK. But all the things we tell you today and that we show are definitely reusable if you use, for example, Pulumi or any other framework that might come up that has the same approach. So don't take this too much as it's an AWS thing, but actually look at some interesting concepts on how it works when you actually code your infrastructure. So what is the AWS Development Kit? It's, and I have to read this off because it's quite long. It's an open source, multi-language software development framework. So this is completely open source. You can find all of it on GitHub. It's there to basically model your infrastructure, and it does so with reusable components. And reusable components might already give you a hint that it's something with programming languages, dry, refactoring, and so on. And what are the benefits if you use CDK or, again, any of those other tools that do the same thing? Well, first of all, it's pretty familiar for you if you can pick your favorite language that you already know. So if you're someone who really likes Python, you can pick Python or TypeScript or Java. And a few other languages, you see all of them at the bottom. Lately, we also added Go as an option. Once you're writing with a programming language, you of course get all the benefits from your existing integrated developer environment, your IDE. So you get things like autocomplete, you find inline documentation, and you get all those things for free, obviously, because it's just code that you're writing. It's just a library, nothing special. Finally, and this is where the cool part comes in that we want to show you today, there's actually an opportunity to abstract things, right? Because now we're programming, and what we're doing in programming is we're trying to create new constructs, new classes that represent a more complex concept, and we try to make it easier to use it. And this is exactly what CDK also tries to do for you. And we will see in a few minutes how this actually makes your job for provisioning infrastructure much easier. Now, at this point, you might go and leave the room because you're thinking, oh no, I took the session where it's just an AWS thing for AWS. But the good news is that's actually not the case here. there are actually multiple variants of the Cloud Development Kit, and you can pick the one that works for your environment. So the one that was invented first and that definitely has the most capabilities is the AWS CDK, and as the name implies, this is for AWS. But then there are at least 2 more variants of CDK. One of it is CDKs. So that one helps you to create all your Kubernetes manifests with a programming language. And then we also have CDKTF, and that is for creating all your Terraform templates with CDK and with programming languages. So that means essentially, no matter if you're doing this on-prem, if you're on another cloud, there's one CDK for you that you can use. And there's even work undergoing where we try to combine those so that you can mix and match depending on what you're doing. For all of those CDK variants, there is a website called constructs.dev, and that website gives you the ability to search for existing open source libraries for CDK, which give you pre-built, pre-made components, bigger architectures that you can just install and import into your project. Now, we talked a lot about a lot of high-level things on how CDK works. So let's take a deep dive on what's actually happening there. So let me quickly move you through the general workflow of how you would work with CDK. First of all, you write what we call a CDK application. And to make this easier, you install the CDK CLI. So of course, there's a CLI tool. And for this, with this CLI tool, you can create basically a scaffold part of the project. So you can scaffold a minimalistic structure that you need to write infrastructure in your favorite language. So you just go to the CLI and say, okay, I want a TypeScript project, and it sets up the basics for you. And from there, you just have to open a specific source code file, and then you start defining your infrastructure there. And you do this by instantiating classes and using functions from the libraries that are provided by AWS. And we will see how this works in just a minute. So we will show you some code. Now, you're writing your code and you are defining your infrastructure. So, for example, you're saying, hey, I want this load balancer that we saw before, or this EC2 autoscaling group. And for all of those things, there are classes that you instantiate and where you provide options. Now, in those classes, which we call constructs, is all the logic to actually define how to roll out that infrastructure in the cloud. So what it actually does behind the cover is, and that's what you see in the middle, once you've written your application, you feed it back to the CLI. The CLI will basically execute your code, and what comes out of that code is a template in some configuration language. And that's the interesting part. So CDK is not directly going to the cloud provider or to Kubernetes and is calling the APIs directly to deploy your stuff. It's actually generating the configuration artifacts that you already know. So for example, for AWS CDK, you get a CloudFormation template. But you didn't have to write it. CDK is doing all of that for you. And if you would use the CDK for Kubernetes, instead you would get Kubernetes YAML. But again, the good part is you didn't have to write it. CDK did that for you. And that's what we sometimes call the assembly language. So there's basically a step in between where CDK produces those configuration artifacts, and then you can apply them as you see fit. So, for example, for CloudFormation, you can take this CloudFormation template and apply it, and your infrastructure is created, and the CDK CLI can actually do this for you out of the box. Or if you're using Kubernetes, you get a bunch of Kubernetes YAMLs, and then you can deploy them however you want. Now, that's an overview of how CDK works from a workflow level, now Bob is showing you a little bit more about how it actually feels like to use Kubernetes, to use CDK, to code with CDK, and actually show you all the magic tricks and the interesting parts of what CDK can do for you. Over to you, Bob.
Thank you, Robert. But let's jump back to the main problem Robert mentioned before with the 300 line of code for YAML. I believe we both have struggled a lot with CDK in the past when we joined the former companies and also the company right now. And right now the question is, how should we benefit from CDK? And there is where the so-named call constructs came in the game, which we can use to represent some resources in our CDK stack we want to build. Regarding that, we have multiple layers, and one layer of them is like layer 1. And layer 1 is representing a one-to-one representation of the cloud formation, which is automatically generated for us. On the second layer, there it is where the magic and it gets interesting happens. And that's where we have like high-level representation of AWS services, where we use like sane defaults and just use it as best practices for deploying into our accounts. And for that, we will jump into a demo in a couple of minutes, where we go through the code. And we have a level 3, and that's like a proposed build construct. It's like an opinionated abstraction of a whole architecture. So what Robert mentioned before with the web service, you can build it as like one class, and you just can provide it over NPM or your internal Git or whatever, and just share it, and you can look like an infrastructure wizard without the 16 years experience, what might be probably needed in the next job description or whatever out on the market. And yeah, so let's jump. So that's the abstraction, so the same defaults and the reusable class we are talking about. So let's assume I have set up my CDK project, probably on my local machine, and then I start typing the first line of codes here. And what I'm starting with is by creating the VPC. And by just typing it into console, you can see there is like an insane auto-completion feature already out of the box, and also inline documentation. What's super cool, I believe, because it's doing all the magic for you. And so I will not read all the bullet points here, but for making it like very, very clear here and give you a short hint what's happening there, with only using like an L2 construct, what I mentioned on the slide before, you can see that the L2 construct is creating a couple of more resources, or creating them for you. So like connectivity to the internet, net gateways, subnets for the private and public, and also the routing and security model for that. Pretty cool. I was excited about that as well, but because only with like one line of code, you have done so many magic, and you don't have to care about writing all this YAML. And yeah, so in the next step, or probably here I can mention, it's like the same defaults and built-in best practices, which you can gather directly out of the box here. And in the next step, and that's the second step we have to do here for creating our web service, is like recreating an auto-scaling group. Of course, we have to pass in some variables like a VPC where we want to deploy it, and so on and so forth. But it's like pretty easy, and you just can put it in there. When we have done that, we have to choose which instances we want to deploy in our network for just running our code. And that's like a pretty cool feature coming out of the box, is like that you can use like types or enums or whatever you want to name them. So you don't have to look into internet what you have to type in there, a string or whatever. Then regarding that, we have to put in some couple more parameters here, like machine image or what we want to deploy, in which subnet. We just type them in, and we say the minimal capacity, as example, we want to scale up to 2. And the last one is like where we firstly just call a function, and that's like add user data to our user group, and that will say, hey, we have a script, so a shell script here, where we say, hey, start my HTTP server, just run in just create a file with HTML in there, and just go for it. Let's run in, and it's like in your favorite language you can choose here, and that's like also pretty nice. When we have done that, you will say, how can we scale that? And with that, and that's the last step here as well for just creating the use case Robert mentioned before, it's like we create like an application load balancer. Also here, we have to put in some parameters like the VPC, if it's internet facing and so on and so forth. But where it gets like very cool, it's like when you can use like convenience functions. The first one we create here is like the add listener. And the add listener we call here and we say, hey, load balancer, please listen to requests coming from port 80. And that's it. After we have done that, we have to say in another convenience function, yeah, with all these requests, where should we go? And therefore, we have the convenience function add targets where we say every request coming in on port 80, just go and just send it to the auto-scaling group we have built before in the code. Pretty cool. So a couple of lines here, and we are running all this. But what about security? And security is also only one line of code, one convenience function here. And also here it's like pretty readable, and you can say allow default port from any IPv4, and this convenient function takes all the steps it needs to configure a secure environment, just allowing traffic from the internet on port 80 going to your machines and just showing you the code here or the website here. What I'm really excited about and what I want to point out here, it's like super clear to read. It's understandable for everybody. I believe when you look at it, there is no magic in. It's also a pretty simple example probably. But here it's like add listener, add targets, allow default port. I believe everybody, also when you're a software engineer or not, you can read it. And also in that moment where I used it the first time, I was like very excited about that. How easily it is, and yeah, how easily we can use convenient methods here. Cool. So let's compare it a little bit. Robert, in one of the first slides, just mentioned, hey, we have CloudFormation templates. It's a native infrastructure definition here from AWS. It's fully declarative. Depending on your IDE, it's very good supported or a little bit less. It depends on the IDE or on the plugins you use there. And it has about 300 or over 300 lines of code, or let's say YAML. On the other side, we have our CDK app. And there, it's like pretty cool because it's an abstraction via code. I believe we are all familiar here with languages, Python, TypeScript, whatever. But also, it's like very it has an imperative aspect here. It's cool. But what makes me very excited here, and that was like one of the coolest parts for me, it's like the built-in sane defaults and best practices. And the YAML I have to take care about what I have to put in here, in which order, and so on and so forth. And here it's out of the box. We only write like one line of code, and it's there. And that's, I don't know if you have counted the lines before, but in less than 30 lines of code, and that's like pretty nice. And I believe we as software developer, we really like that. Write less, be more effective, and so on and so forth. Also within AWS, when we launched that, I can remember me being very excited, going to all my colleagues, hey, CDK, I was so productive. And it was like super fun, because otherwise it has took like half a day for just building like a couple of services. And right now it took me like 30 minutes, 1 hour maximum, and with a short amount of code. And it's testable in all the best practice here. It's great. I'm very, very likely here, and I'm a big fan of it. And whenever I can use it also right now in new project, in older project, I will use it. When there's no way around, probably I will skip it. But when there is like a way to use it, I will always use it in the language I like most. So, why should you use infrastructure or code your infrastructure? I have a few bullet points here, and I believe that's how it looks like. So it's about the developer experience. I believe we all have set up an IDE. We feel familiar with it. We have the program languages we feel comfortable with. We profit from great IDE support, as example, by auto-completion or inline documentation. And that makes us really fast, because we don't have to jump between your IDE and internet and so on and so forth. And of course, we have the powerful abstractions to build smarter, faster, and more understandable. That's what I mentioned before. So everybody who reads your code can understand what you want to do here with only a couple lines of code. When you see a YAML, it's like, oh, 300 lines of codes I have to study. And of course, it brings your code and your infrastructure closer together. So why not? I believe, in my opinion, there's no why not, but it's also a tricky question. No, just kidding. There are a couple of why nots, and one of them is like, if you don't feel comfortable, or you feel more comfortable by using Terraform, CloudFormation, etc., or Pipi, I believe it's not a good choice to go with CDK. So go with the tooling you have in place right now. Another point would be like when you don't feel comfortable by coding or debugging. Sometimes you have to do it, and when you don't feel comfortable, it's not the right piece for you. But the good part here is like you can mix and match. So probably you have an infrastructure team who is using like CDK, you have other teams using another language, and you can mix and match it, and you can come closer together, work more effective. And that's like pretty cool. So yeah, that's what makes me as well like really excited that we can mix and match, and there is like no good and bad. And yeah, so coming to that, I will ramp up a little bit here because it's also coming to an end. If we have just show you some use case, probably you want to use CDK, I can recommend to go to cdkworkshop.com, so you can play around with the AWS CDK, but also the CDK there was in the past. There are pretty nice recordings you can look at. Also, when you want to dive deeper a little bit, there are a lot of links we can share in a couple of minutes after the presentation here. So for Terraform, for Kubernetes, also for CDK pipelines, very impressive talks out there on the market. Go and have a look, go out and build. And also here, if you build something very nice or also a smart things and you get excited about it, hey, reach out to me and Robert on Twitter, LinkedIn, whatever. Just tell us the story. We are always happy to hear people just building great stuff with it. I believe I can say it for us both that we are also very happy to see that people are going out and build with it and share it. And of course, when this talk was good, I would be very happy if you can rate it. Probably you can scan the QR code here and just rate the presentation, how we can make it more enjoyable, better, or improvements. Very appreciated. And yeah, thank you for your time. And if there are any questions, I will give you the word.
Thank you so much for the talk. We have plenty of questions.
Awesome. Maybe just one very quick note from me. So thanks.
Go ahead.
Thanks a lot. We just posted, so if you have the CDS app, which you should have, obviously, I need to say that. Just joking. If you have the app, we just posted to the newsfeed all the links you saw on the slides, so that makes it much easier for you to go along. Sorry.
Go ahead.
All right. How does CDK fit into the GitOps workflow, which some people view as strictly declarative? Yeah, so it fits pretty nicely because as you've seen when I showed how it generally works, you always know that the output is a declarative template. So the code you write, of course, that's not declarative. It's code, right? It's Turing complete. It can do bad things because it's code. But the output is a declarative template. And you can use that declarative template in all your workflows like GitOps, where you previously used declarative stuff. So for example, for Kubernetes, you just could take this Kubernetes YAML, put it into your GitOps workflow, have the control loop run it over and over again. So I think there's some compatibility there. How do we collaborate between teammates when everyone wants to use their favorite programming language or don't have knowledge in a common one? Oh, that's an awesome question. So one thing we didn't talk about so much is that basically CDK has built-in support for all these different languages, and there's actually a tool that's also provided from Amazon that transpiles your CDK libraries, even the own ones you're writing, into other languages. So you can come from one language, but release it basically in all the languages. And of course, you could do this internally at your company. How can I make sure that my code is working as expected? Do I need to have access to AWS services to do so, or can this run offline? So, I guess behind that there's a general question like, I'm working with the cloud or with Kubernetes. How do I know if my configuration is right? And there have been various approaches to do that, right? No matter what platform you're using. Like sometimes there are simulators where you can do it locally and it acts like it was the cloud. But I think more and more what I see is people go to basically apply this in the cloud directly to see if it works and then tear it down. So ideally you have access to an AWS account. One note here is that you can test this stuff, which is interesting, right? Because it's code. So you can write tests for that. And if you do the workshop or any of the other examples, it shows even how you can test it. So you would verify, does it create this or that resource? And that, of course, you can run offline. What's the best practice to migrate from an existing Terraform project? So most of the CDK libraries, CDK tools, they have an import function where you can basically take an existing template, import that, and even take this import and cast it to the objects in CDK. So you could start out with your existing template, put it in CDK, leave it as it is, you can still apply it, but then start to sprinkle in more CDK magic as you go along. I feel like we add a lot of abstractions. I could make a stop there. It's a good sentence. Yes, we're adding a lot of abstractions for everything. That's how our world works. True. On top of existing tooling, other ways to ease with the debugging when an intermediate layer breaks. It's a good question. I think that's where CDK took the right approach by saying you're not writing that code and then it somehow magically applies it in your cloud or your cluster, but it's actually producing this intermediate artifact with a configuration language. And again, this is the standard configuration language of the environment, like CloudFormation or Kubernetes YAML. So there you can inspect it, you can share this with a community, and everybody knows what it is, right? You don't have to tell them how you generated it, but you can still discuss that. So I think that helps you to bridge that gap. Do you plan to deprecate CloudFormation in favor of Cloud Development Kit? No. Actually, as you have seen, they both depend on each other. CDK is basically a generator that takes code and makes CloudFormation out of it. So it wouldn't work without CloudFormation. And we always want to give our users the choice of what they want. Is CDK applicable for bare metal Kubernetes clusters? Okay, I answer this. Yes, if you use the CDK, so CDK 8S, that works perfectly with any Kubernetes in the cloud or bare metal.
Thanks.
Thank you very much. We still have a lot of questions, but sadly we have other talks coming up. So if you have any more questions, I would suggest you to join these guys in the venue and ask whatever the questions. Thanks for coming to this talk. And again, please have a big round of applause for our speakers.